previous video, we saw basics of trigonometry. In this video, we will see some of the applications of trigonometry in real life. Trigonometry has lots of applications in the real world and can be used in many practical situations around us. They are mostly used in finding the heights of things such as towers, buildings, or they are also used to find the distance between two things. How do we find these heights and distances using trigonometry? Let us see that with the help of an example. But first, let's talk of one more important thing before I put a question on the screen. We have seen trigonometric ratios of angles of a right angle triangle. Hence, forming the right triangle from the given question is the most important step while solving problems. Now, I will put a question on the screen and you try to sketch out a right triangle from the given information. Let's start with a simple example. Read the question carefully and try to form a right triangle. Here we are given a wall. You can represent the wall with a vertical line like we have done here. You don't really need to draw an actual wall. Now it's obvious that this wall makes an angle of 90 degrees with the ground surface. That's something we can definitely assume. We are also given the height of the wall as 20 meters. A ladder is inclined against the wall like this. Again, you can represent the ladder with the inclined line just like we've done here. What else are we given? We are told that the angle made by the ladder with the surface is 30 degrees. That is, this angle is 30 degrees. And finally, we are asked to find this length, that is the distance between the foot of ladder and the bottom of the wall. Now, some of you may be wondering if we could have drawn the ladder on the other side like this. Guess what? It will not make any difference at all. So we will take the one we'd done originally. So here we have our right triangle which pertains to this problem. It was easy to form, wasn't it? Let us name its vertices as A, B and C. Okay, let us solve this quickly now. We are given the measure of angle C here and we are also given the length of its opposite side AB. We are asked to find length of BC. Which trigonometric ratios we will use here? Sine, cos or tan? BC is the sine adjacent to angle C and that's what we are interested in. Now let's understand this well. Length of BC is what we want and the length of AB is what we have. They are opposite and adjacent sides of angle C. What does this tell us? It tells us that we should use that trigonometric ratio of angle C which involves opposite and adjacent sides. What will be that ratio? It will either be tan or cot because these two involve both opposite and adjacent sides of an angle. Let's go with tan here. We see that tan C is AB over BC. Now all we need to do is substitute the given parameters. What is tan of 30 degrees? If we remember from this table, tan 30 is 1 over root 3. We get 1 over root 3 equal to 20 over BC. Solving this further, we get BC as 20 times root 3. Don't forget the unit here, which is meters. So the distance between the foot of the ladder and the bottom of the wall is 20 root 3 meters. You would have got the same answer if you would have used cot instead of tan as well. We will leave it as an assignment for you to verify that. In the next video, we will look at another example. See you there.